You guys, it's been so long since I've been able to do the distributive property, but we're finally to that section. Are you excited? I just love the distributive property. It's like one of my favorite. It's easy. It's just, you just put in the number. It's so much fun. Later on in the year, we'll get to do it backwards. Anyway, today's distributive property day, and I am pumped. The essential question is, how do I use the distributive property to simplify expressions? Now, before we get to all the fun, we need to talk about what expressions are exactly and some different vocab associated with them. Here's an expression. This whole thing is an expression because it's a collection of math symbols and variables. There is no equal sign. That's not there, otherwise it'd be an equation. It's just an expression. So let's do some vocab. First of all, terms. Terms are separated by pluses or minuses. So this is a term, this is a term, this is a term, this is a term, and this is a term. See how I'm separating them with pluses and minuses? I think I'm going to do the terms in boxes just so that you can see. And I really like to think about the sign to the left of the term as that term's sign. So here are all of the terms. Excellent. All right, the next thing we need to do is the coefficient, and I'm going to circle the coefficient. A coefficient means that number that's in front of the variable. So this guy is a coefficient, that -3, because it's in front of the variable multiplying it. This -5 is a coefficient. This -7 is a coefficient. Let's talk about this term right here. I don't see any coefficient. What would go there? What number could I write in front of the x? Since there's just one x there, mathematicians know that this means 1x. So the coefficient, if there is no coefficient, is assumed to be 1. Notice I did not write 0. The coefficient's not 0. There aren't 0 x's, there's 1x there. Let's talk about the constant term. I'll put a triangle around this guy. The constant term is the sad, lonely guy at the end, kind of like the kid at recess that nobody would play with, and he is the guy without a variable. So it's not just because he's at the end, it's because he has no variable attached to him. That's what a constant term is. There's no variable. He's sad, he's lonely, he doesn't have a variable to be friends with. All right, now I'm going to erase all of this because we need to talk about like terms. So let me get rid of these things. The like terms, you can have like terms if the variables after the coefficients are exactly the same. So let me write that. The variables, I'll just write the variables are exactly the same. So let's look at this problem. This first term, it has an x squared. Let's not worry about the -3, just worry about the variables, x squared. That is a like term with this x squared. It is not a like term with this x, or this 3 because those terms don't have an x squared. Likewise, let's double underline the x. Double underline because it's not the same term as a single underline. This x is like terms with this -7x, again, because they both have an x. And this 3, remember that was the constant term. He has no variable at all, so he is all on his own. He is not like all of the other ones. He found a new way to be lonely. When we're doing these problems, we'll be able to combine like terms, and I'll talk to you about how we're going to do that later on. So let's get into some problems. Oh, exciting, the distributive property. We get to use the distributive property to simplify each of the following. I hope you remember how to do this. It's kind of like you multiply the -4 times the x, and you multiply the -4 times the -5. So here's how it looks. The distributive property means, since this -4 is multiplying the parentheses, I am allowed to multiply it times the x by itself and the -5 by itself. So let's do it. -4 times x is -4x. And -4 times -5, remember with terms we take the sign in front of it. -4 times -5 is +20. We talked about a negative times a negative is a positive. Let's look at this expression. The parentheses are gone because the distributive property kills parentheses. Also, do I have like terms that I can combine? Here's an x This guy, no x, he's a constant term. I have no like terms I can combine, so this is my final answer. Next problem. Uh-oh. I have parentheses first and then the thing that's multiplying them. Is that okay? Can I still do the distributive property? Absolutely, because we love the distributive property. All I have to do is multiply this 3n in to both the 5n and the 6. Don't get messed up by the fact that it's at the end. That'll happen sometimes. Okay, 3n times 5n. So remember the rule here. I'm going to multiply the coefficients. 3 times 5 is 15. And then what's n times n? This is a good fact to know. Remember that a number times itself, we can put an exponent. So since it's the same thing times itself twice, I can just simply write n squared. So 15n squared. Then doing the 3n times positive 6, remember keep that sign to the left, that would be positive 18n. Are these like terms? No, because this guy has an n squared, this guy has just an n. They have to have exactly the same combination of variables. They don't, not like terms. This is my final answer. Woo, we're moving right along. Let's do some more distributive property. Okay, in each of these problems, I see that I have the parentheses, and then I have this other little guy hanging out at the end here. I want to use distributive property first, because before I can subtract the 8, PEMDAS says I need to multiply, and multiplication in this case is the distributive property. So do the distributive property first in almost all cases because multiplication comes before subtraction. So 3 times m is 3m, 3 times negative 4 is negative 12n. Again, keep this sign. And I said negative 12m, I meant just negative 12. Then we have this little negative 8 over here that didn't have anything happen to it, so let's rewrite it. Okay, at this point I do have some like terms I can combine. Not this m, he's not a like term, but these two guys, they're like terms. And so I can literally take negative 12 minus 8, that gives me negative 20. And so my final answer is 3m, who didn't have any other like terms, minus 20. Nice. Okay, let's talk about this problem. Now, I see parentheses, but I don't see any number written here. Remember what I said we can put when we don't see a number? Like I know I should be distributing something in to get rid of the parentheses, but what's that something going to be? And remember, we said if there's nothing in front, there's a little invisible 1 there, because I know there are just one of these parentheses. In other words, 1 parenthesis, so 1 times the parenthesis. Now remember, when I'm distributing this in, I'm not just distributing in 1, I'm distributing in negative 1. Remember, for our terms, we always keep the sign to the left. Even though that looks like a minus 1, I can also treat it as a negative 1. So I'll write the 13x, we haven't used that. Then I'm distributing in negative 1. Negative 1 times x is negative 1x, or just negative x. Negative 1 times negative 7 is positive 7. Negative times negative equals positive. Okay, I have like terms here, right? Here's an x, here's an x. Remember, this is negative 1x. So 13 minus 1 is 12x. When you're combining like terms, the variable stays the same. Here are 13 x's, here are negative 1x's. When I put those together, think about the piles of pluses and minuses. Now I have 12 x's. And then this plus 7 on the end did not have a like term. It is, do you remember? The constant term. All right, that's it. I'm good to go. Ooh, find the area and the perimeter of the following rectangle. The rectangle appears. I love the magic of video editing. It makes me smile to myself and just gives me a warm feeling on the inside. Now, I need to remember some things about rectangles because if I'm trying to find the perimeter and the area, I need to know some things. First of all, let's think about what the perimeter is. The perimeter of any figure means add up all the sides. So if I was doing the perimeter of this really simple triangle, I'm adding up all the sides. 3 plus 4 is 7. 7 plus 5 is 12. Here's the perimeter of the triangle. I added up all the sides. The area is going to be the area of a rectangle, if you remember, is length times width. Length is with a W that I like doing in cursive so it doesn't look like a 1. W means width, and I do it like a W because it's a W. Now, I need to remember some other things about this rectangle. First of all, if this side is x plus 7, do you remember that this side across from it is the exact same thing? So I can label that side as x plus 7 as well. Same thing with this side. The side across from it is also going to be 2. That's a property of rectangles you should know. So let's do the perimeter first. The perimeter literally means add up all the sides. Okay, so I'm going to do 2 plus x plus 7 plus 2 plus x plus 7. And that's the perimeter. So I'm almost done. I just need to simplify by combining like terms. Here are two like terms. I really like to underline them like that to let me know I got rid of them. This 1x plus this 1x means that there are 2 x's total. And then I have a bunch of numbers that I can combine. 2 plus 7 is 9, plus 2 is 11, plus 7 is 18. So my perimeter is 2x plus 18. Word up. Now keep in mind, the reason that I can do the combining like terms out of order is because of the commutative property. Commutative property tells me that if I want to add these x's together before adding everything else together, that's totally fine. I can change their orders and add them first. Let's now do the area. I said the area was length times width. I don't really know what the length and the width are here. Can we call this the length and this the width? Is that okay? Like, I could switch them. This could be the width, this could be the length, whatever. So length, x plus 7. Let's remember to put that in parentheses. Remember how when I'm plugging in, I really like to do it in parentheses? And then the width times 2. Let's also put that in parentheses. Do you see the distribution I should be doing? I have a term here that has a plus in the middle. And over in this parentheses, it's just 1, 2. So notice how this looks like this problem. I have parentheses with a plus in the middle times just one thing. I can use distribution. So I'm going to distribute in the 2. 2 times x is 2x, and 2 times 7 is 14. And that's the area of this rectangle. Awesome. Just a quick summary, guys. I know this was a longer video, but remember, the distributive property is the way to kill parentheses. If you want to get rid of parentheses and there's something multiplying them, distribute that in. It will get rid of those parentheses. Remember, like terms have the exact same variables, so x's go with x's. X's do not go with x squares. X squares go with x squares. These are the like terms. And to combine like terms, I add and subtract the coefficients. So if I have 7x plus 2x, all I do is add 7 plus 2. I now have 9 x's. That's how you combine like terms. Guys, thanks for watching, as always.